It was a proud moment when the Andromeda cloud became the Andromeda galaxy for a big time. Describing the Andromeda system is limited to terrestrial observations. But with the advancement of technology and the introduction of the James Webb Space Telescope, our knowledge has grown to infinity. Now all that has changed, as the James Webb Space Telescope has detected disturbing signals coming from the Andromeda galaxy. These signals sent shock waves through the scientific community and excited astronomers. What do these symbols mean? Why is there so much fuss among astronomers? Join us as we examine when the James Webb Telescope was shut down after receiving an ominous signal from Andromeda. Before, our eyes could only see a small part of the world. Astronomers believed that the Milky Way was the entire universe. Due to limited technology, it is impossible to explore beyond our galaxy and stars. Everything changed when the Andromeda galaxy was discovered. This is our first evidence that the universe has extended beyond the Milky Way. The journey began in the 17th century, when Galileo Galilei's pioneering work with telescopes revealed the true nature of the Milky Way. He saw that the Milky Way had so many stars that he challenged the idea of its own special significance. The most significant change occurred in the 1920s, when Edwin Hubble discovered celestial bodies beyond the Milky Way. Using the Hubble Space Telescope, Edwin discovered that these objects were distant stars, unlike the Milky Way. One of the galaxies is the Andromeda Galaxy, also known as M31. Although this is the first time we have seen Andromeda through a telescope, it was first discovered by the Iranian astronomer Abd al-Rahman Sufi around the 1000s. Scientists believe that to better understand the universe and our galaxy, we must focus on the connection between Andromeda and the Milky Way. This is important because the two galaxies will collide in about 4 billion years. As research progressed, the James Webb Telescope recently received a disturbing signal from Andromeda. This strange sign has puzzled experts around the world, raising questions about its origins and potential implications. The James Webb Telescope sensors have detected unusual activity in and around Andromeda's core. The results presented to experts show results that are very different from previous findings, surprising scientists around the world. This signal indicates important activity in the galaxy, possibly related to its supermassive black hole or previously hidden features. One of the most surprising discoveries is that Andromeda may be larger than the Milky Way, changing our understanding of the size of both galaxies. The James Webb Telescope has provided images and features of Andromeda that reveal new star formation and chemical composition. These new data are important to understanding the macroevolution and dynamics of galactic life. In addition, data from this telescope indicate increased activity in the region of Andromeda's dynamic center, which may shape its future formation. By studying the effects of the halo on Andromeda's stars, scientists can understand the distribution of dark matter throughout the galaxy. This development gives us a better understanding of the mysterious role of dark matter in galactic dynamics. Continuous improvements to the James Webb Telescope sparked research around the world as scientists unraveled Andromeda's mysteries. As more information is revealed, we learn about the past and future of the galaxy. What have we learned about Andromeda through various studies? Andromeda has shown remarkable properties that set it apart from other galaxies in the universe. Its size alone is impressive, with estimates around 220,000 moon-years across, making it one of the largest galaxies in the local group, larger than the Milky Way. It is estimated that there are 1 trillion stars, larger than our galaxy. Scientists also find its structure fascinating. Unlike a typical spiral galaxy, Andromeda has a pulsating center with a dense core surrounded by rings of dust and gas, fertile ground for star formation. One of the most interesting features of Andromeda is the appearance of 2 peaks in the middle, indicating the presence of a supermassive black hole. Although different from the Milky Way, Andromeda is surrounded by a galaxy of stars, planets, and star clusters spanning tens of thousands of light-years. This large folder tells the story of the formation and unique history of the galaxy. The 460 globular clusters found in Andromeda are a great insight into the early stars, giving scientists a better understanding of its early evolution. Unraveling the mysteries of Andromeda will bring astronomers closer to the depths of dark matter. However, one question remains: how can we explain its bright nature and its role in the formation of galaxies? Another feature of Andromeda is the satellite galaxies. There are more than 20 smaller galaxies in the main structure, some of which are missing stars and gas due to Andromeda's pull. This process of pulling large galaxies into smaller galaxies shows how galaxies continue to evolve and how they interact over time. What is the future of the Andromeda galaxy? Nature and development are fascinating to astronomers. Andromeda's ability to transition from a spiral galaxy to an elliptical galaxy is important to its evolution. Evidence suggests that Andromeda has had many interactions with other galaxies since its formation, and that future mergers may result in more positive changes. Ultimately, Andromeda is bound for its inevitable collision with the Milky Way. According to current models, this collision is expected to occur within 4 billion years. The result of this great event is the creation of a new galaxy containing these two giants. Although this collision is dangerous, it is a natural part of galactic evolution. However, due to the great distance between the stars, this fraction of the world does not stay close. After the collision, the shape of the two galaxies is destroyed and a new structure is formed. The combination of wind and dust stirs up new waves of star formation, creating a spectacular cosmic display as the combined objects flash across the sky. This galactic event leads to the formation of a single elliptical galaxy. Although these encounters in the world are not unique, our participation still makes this event important to us. The collision of supermassive black holes between two galaxies adds an intriguing layer to this cosmic drama. This fusion is supposed to produce intense radiation from the material consumed by the black holes. This event provides important information on the evolution of galaxies during their lifetime and the effect of black holes on this process. But that raises a big question. What will happen to the solar system after the merger? Although the total destruction of our solar system is unlikely, it will change the way it works. This causes changes in the Earth's cycle, which may affect the climate. A change in orbit causes the planet to warm or cool. A warmer Earth will likely see the ice caps melt and sea levels rise, while a colder Earth will enter another ice age. The merger of the Milky Way and Andromeda will affect the distribution of radiation reaching Earth, potentially making life more difficult. The collision of supermassive black holes between two galaxies will increase the levels of high-energy radiation reaching Earth, threatening biodiversity and possibly causing extinction. Scientists are studying this phenomenon to understand how these cosmic mergers affect the stability of star systems. Although collisions between stars are rare due to the great distances between them, gravitational disturbances can throw stars, including our Sun, off course. This has great benefits for the country and its environment. In short, the combination of the Andromeda and Milky Way galaxies illustrates the complex relationships between celestial bodies. When the black holes in the center of the two galaxies come close together, their interaction results in the emission of high-energy particles that impact the Earth's environment. Rising radiation levels accelerate the rate of change and threaten biodiversity. In addition, the change in the Earth's orbit or axis due to the black hole merger will have a strong impact on the climate and the ecosystem. The collision between Andromeda and the Milky Way shows the importance of studying the differences between these two galaxies. This knowledge will help scientists create more accurate models of dynamics and evolution. The reevaluation of Andromeda's size and mass is very important, as it has challenged our previous assumptions and led to a reevaluation of its role in the local group of galaxies. Recent data shows that Andromeda is about the same size as the Milky Way, contrary to previous assumptions that our galaxy is larger. This new understanding challenges the Milky Way's status in the local and global sphere of influence. Although the Milky Way is currently a spiral galaxy, its composition may change due to the interaction with Andromeda and the upcoming collision. Andromeda's observations are helping scientists better understand the forces that drive changes in the universe and how galaxies evolve over time. Advances in telescopes are important to these discoveries. From the development of early telescopes that allowed astronomers to observe the moons of Jupiter and the phases of Venus to the creation of modern space telescopes such as Hubble and James Webb, each advance has opened up new doors to understanding the world. The introduction of the Hubble Space Telescope in 1990 was a major leap forward in space exploration. By observing the universe from above the Earth's atmosphere, Hubble removed many of the distortions caused by the Earth's atmosphere and produced clearer and more detailed images than ever before. Of the past, Hubble's contributions helped scientists better understand black holes, the age of the universe, and its continued evolution. The James Webb Space Telescope, the successor to Hubble, represents the pinnacle of space technology. With its advanced capabilities, It promises to delve deeper into the mysteries of Andromeda and other galaxies, providing rare insights into star formation, dark matter, and the workings of black holes. The Webb telescope can look at dense clouds of air and dust that obscure objects from visible light. This opened up new avenues for astronomers, allowing them to observe phenomena that were previously hidden. Through online observations, we can better understand how galaxies grow over time and how black holes affect their environments. Overall, the James Webb Space Telescope is pushing the boundaries of our knowledge and revealing the dynamic interaction between galaxies and their environments. The findings challenge existing theories and raise new questions, asking us to rethink our place in the world and the forces that shape it.